Hello students, Namaste to all. Today we are going to discuss about depression in freezing point of solvent. It is one of the colligative properties for dilute solutions. Colligative properties means the properties of dilute solution which is containing non-volatile solute depends on number of the solute particles like ions, molecules and atoms, but it does not depends on nature of the solute. Such properties is called colligative properties. There are four colligative properties are there. One is relative lowering of vapor pressure. Second one, elevation of boiling point of the solvent. Third one, depression freezing point of the solvent. Fourth one, osmotic pressures. In before videos, we already discussed two colligative properties such as relative lowering of vapor pressure and second one, elevation of boiling point of the solvent, completed in before lecture videos. Now we are going to discuss about depression freezing point of the solvent. So before that, we discuss freezing point. Freezing point. The temperature at which the vapor pressure of the liquid state becomes equal to vapor pressure of the solid is called as its freezing point. That means vapor pressure of liquid equal to vapor pressure of solid. Once again here, the temperature at which the vapor pressure of the liquid becomes equal to vapor pressure of the solid is called as its freezing point. At freezing point of the substance, liquid and solid state both are in equilibrium state. At freezing point of the substance, then liquid and solid phases are in equilibrium. Or in equilibrium. Now, depression freezing point of solvent we'll discuss in graphical methods. Okay, look here. Here vapor pressure taken on y-axis, temperature taken on x-axis. Here. Now, when non-volatile solute is added to solvent, then vapor pressure of solution decrease okay. Look here, this is the solution The solution containing solute, it is a B compounds, it is a solvent, it is a A compounds. Non-volatile solute added to the solvent, then vapor pressure of the solution lower or decrease. Here solute means we have taken B components, solvent means we have taken A components. Look here. Now graph drawn in between vapor pressure and temperatures. Vapor pressure taken on y-axis, temperature taken on x-axis. Now look here. This curve indicates this is the vapor pressure of pure solvent. This is the vapor pressure of pure solvent, pure liquid solvent. When non-volatile solute added to the solvent, then vapor pressure of solution decreases. This curve indicates solution which is containing non-volatile solute. Okay. Now look here. What is the freezing point? The temperature at which the vapor pressure of liquid becomes equal to vapor pressure of solid. That means vapor pressure of solid which is equal to the vapor pressure of pure liquid solvents. Now this line indicates vapor pressure of solid. The vapor pressure of solid which is equal to vapor pressure of the liquid. At this point indicates this is the freezing point of pure solvent. It is denoted by T naught F. So this point indicates freezing point of pure solvent. So which is denoted by T naught F. So this line can be extended like this. At this point indicates freezing point of solution. It is a TF. This point indicates freezing point of pure solvent which is denoted by T naught F. This point indicates freezing point of solution which is denoted by TF. We look here. The freezing point of solution is always less than freezing point of pure solvent is nothing but depression in freezing point. So this area indicates depression in freezing points which is denoted by delta TF. Delta TF is equal to how to get? Is equal to T naught F minus TF. T naught F minus TF. So delta TF is nothing but depression in freezing point. So based on this equation we can say the freezing point of solution is always less than that of freezing point of pure solvent is called depression in freezing point. Or the difference in between freezing point of pure solvent and freezing point of solution is called as depression in freezing point. Okay. Look here, this depression freezing point is act as a colligative properties here. So this colligative properties depends on number of the solute particles, but it does not depends on nature of the solute particles. So delta TF, depression freezing point, is directly proportional to concentration of solution. So concentration of solution means it having lot of methods. One is molarity, molality, normality, mole fractions. These are the concentration methods. But here the depression of freezing point delta TF is directly proportional to the molarity. So molarity is the independent of the temperature. That's why colligative properties is directly proportional to the molarity. That means the depression freezing point of solvent is directly proportional to the molarity. Look here, delta TF is directly proportional to molarity. Delta TF is directly proportional to small m. Small m is molarity. Delta TF is equal to Kf into m. This is for non-electrolytes. Here Kf is proportionality constant. And also called cryoscopic constant. Cryoscopic constant. And also known as molar depression constant. This Kf can be derived from this formula. Kf is equal to R into molar mass of solvent into T naught F square by 1000 into change in enthalpy for fusion. Kf can be derived from this formula. So different compound having different Kf values. Different compound of solvent having different Kf values. Actually, this derivation no need for here. Okay. This equation for non-electrolytes. For electrolytes, we are used want of factors. Delta TF is equal to I into Kf into M. Here I is the want of factors. I is the want of factors. Okay, I means here number of ions from solute. Okay. From these equations, delta TF is equal to Kf into molarity. Do you know that molarity means number of moles of solute by weight of the solvent in kgs. So delta TF is equal to Kf into number of moles of solute means Nb by weight of solvent like a Wa in kgs. Now look here. delta TF is equal to Kf into number of moles of B means weight of the solute by molecular weight of the solute into 1000 by weight of solvent in grams. Delta TF is equal to Kf into Wb by Mb into 1000 by Wa in grams. Here delta TF means depression in freezing point, Kf means cryoscopic constant, Wb means weight of the solute, Mb means molecular weight of the solute, Wa means the weight of the solvent. Okay, by using this equation we can easily calculate molar mass of the solute. Okay, this is the depression in freezing point of solvent. Now we discuss units of Kf. So do you know that delta Tf is equal to Kf into molarity? I want the units of Kf. Kf is equal to delta Tf by molarity. So delta Tf measured in terms of Kelvin, molarity units is mole per kg, that is equal to Kelvin into kg into mole inverse is the units for Kf. If molarity is equal to 1, then delta Tf is equal to Kf. That means the depression freezing point of 1 molar solution is called as molar depression freezing point or cryoscopic constant. Okay. Now, if m is equal to 1, delta Tf is equal to Kf. That means here the depression in freezing point when 1 mole of non-volatile solute dissolved in solvent, or the depression freezing point of solvent of 1 molar solution is called as depression freezing constant or cryoscopic constant. Now we are going to discuss problem based on the depression freezing point of solvent. Look here, problem: 1 gram of non-volatile solute dissolved in 50 grams of benzene lowered the freezing point of benzene by 0.40 Kelvin. The freezing point of depression constant of benzene is 5.12 Kelvin kg mole inverse. Then calculate molar mass of solute. Here benzene act as a solvent here. This is act as a solvent. Okay, the non-volatile solute. How much is given? 1 gram. Okay. Look here. First we write the data from the problem. So weight of the non-volatile solute, how much is given? 1 gram. That means Wb is equal to 1 gram. So now we can find out molecular mass of solute. This is a question. Weight of solvent is given. How much is given? 50 grams. Wa is equal to 50 grams. Look here. Benzene is lower the freezing point by the benzene is 0.40 K. That means depression freezing point is given. Delta Tf is equal to 0.40 Kelvin is given, and Kf is given 5.12 kg Kelvin mole inverse. Then calculate molar mass of solute. So according to the depression freezing point of solvent, delta TF is equal to KF into WB by MB into 1000 by weight of solvent in grams. All these values substituting this equation to get MB value. That implies, what is the delta TF value? 0.40 is equal to KF value 5.12 into WB value 1 gram into 1000 by MB into weight of solute 50 grams. Then MB is equal to 5.12 into 1 into 1000 by 0.40 into 50. Simplify. Then MB is equal to 256 grams. It is the molar mass of non-volatile solute. This is the molar mass of non-volatile solute from this data. Okay boys, this is the today's session. Thank you.